Alright, in this video we are going to look at solving systems of equations with three variables. And you will notice that here we have three equations, but we have three variables as well, an x, a y, and z. And when you have three unknowns, the only way to truly solve is if you have three different conditions. So you have to have three sets of unknowns. So we're going to look at how to solve this through elimination on the first day here. So this is going to be the same basic method that we covered when we covered eliminations with two variables. So this should look familiar here. Let me just cover this up. There we go. So here, if we had these two equations, we said, hey, those z's there, they're the same, they're just not opposite signs. So on the second equation, we could multiply that second equation through by a negative. And when we do that, look, the z's cancel out, which then leaves you with negative 4x equals negative 16, and x equals 4, and then we were able to plug back in. So when you have three equations, three variables, what you're really trying to do is go from three equations, three variables, down to two equations with two variables. And that's going to be our ultimate goal. So looking at this process, I'm going to show it to you here first, and then we'll actually step you through it. So if we look at these equations, and normally you try to number them, you can say, well, looks like the y's here can cancel very quickly. So if we added equation 1 and 2 together, the y's would cancel, and you'd be left with an equation with just x and z. So we have an equation with just two variables, and the variables are x and z. Well, we would be able to solve a two-variable system if we had a second equation that also had x and z in it. So say, well, can I use any of the other two equations here and also eliminate y so we get to another equation with x and z? Well, look, equations 2 and 3. We've got a negative y and a positive 2y. Well, if I multiply that second equation through by 2, that'll get me a negative 2y there and a positive 2y there. Those would cancel. So here's the work here. If we take equations 2 and 3, we multiply the first equation through by 2. You can see all the terms get multiplied by 2, and we get a negative 2y there. And if you then bring your third equation here over, you don't need to do anything to that one. And here, those go ahead and cancel. So those cancel. You're left with 7x plus 3z equals 25. So now this equation has x and z. The equation that we started with over here also has x and z. Well, now you have two new equations with the same two variables. So what you could actually do is, if we just ignored everything we'd done up to that point, and we just used this equation and that equation, we could just start the problem all over again, which is where I started off here. These are both 3z's. I can get rid of the 3z, and those cancel, and now you know what x is. Once you know what x is, you can plug back into one of your equations. Here I plug this over here, plug the 4 in for the 7x. That found out what z is. Once you had x and z, you can plug back into one of the original three equations and find out your y. Okay? So what I'm going to do is I'm going to actually work through this whole process in the next video.